Hello there, Jay here from Jay's Vintage Junk, and quick update on the little record player project. First, apologies I've not made any videos in the last week, but I've been very busy with work. As some of you know, I'm self-employed, so basically when the work comes in you can't exactly turn it down, so unfortunately videos have had to go on a bit of a back burner while I just get rid of a backlog of jobs I've got to get done for people. But I have been having a little bit of a play with the project. I'm not completely happy yet. Basically, I've made some preamps, which they've worked, but I'm still not. I still think that the cartridge can do better. I know it's a super cheap little nasty cartridge, but I've seen these cartridges perform really well. Must admittedly mostly using valve preamps. The main problem we've got here, and one of my viewers pointed it out in the comments section, basically what we're struggling with is we've got a ceramic cartridge which is a very high impedance output, and we're trying to drive an amplifier which is expecting really quite a low impedance input. Now, to get around, there's a few different ways we can get around that. First one I tried is actually this little board here that I made, that I think I showed in one of my previous videos. It's just a simple little one transistor preamp. It's just, I think it's a 2N222 or something like that. It's just a general purpose generic little transistor. Now that worked, got plenty of volume and everything, but it sounded quite tinny, as these cartridges can do, because there's no matching there, it's just a little bit of amplification. So what I tried is, I tried putting what's called a low pass filter on it. So basically with a capacitor and a resistor on the input, which would basically roll off a lot of the high frequencies and just let through the low frequencies. Now that did help, that worked actually quite a lot. The problem with it was, then when you further wanted to use a tone control on it, it sapped all the volume. When you actually got it down on the lower, on the bassy side of the tone control, it sapped all the volume out of it. It was all basically just being drained away. So I thought, right, what we need to do is we need to sort out that problem with the impedance matching. Now, like I said, the valve is a very good way of doing that, but we was trying to keep this thing all solid state, although using a valve hasn't completely gone out of my mind. I've got an idea possibly for using a valve, but it'll be a bit interesting because it'll be running on a very low HT for the valve. I've seen it done with I can't remember if it was an ECC83 or an ECC82 in the past, running on like about 28 volts DC on its HT. We might have a look at something like that, but what I was also playing with is another device which is quite good. It's got high for a high impedance input, is an FET, field effect transistor, and I found a couple of circuits online using N-channel MOSFETs, FETs. Basically, it's not giving any real amplification, but it's taking that high impedance load and giving something out which is a lower impedance signal. So basically it's acting as a matching. Now again, I had a play with that. Now problem was I didn't have any low voltage N-channel MOSFETs kicking about anywhere. All the new ones that I've got are like switching, the first switch mode power supplies and lighting dimmer circuits and things like that, so they're like 400 volt rated, and I wanted a low voltage N-channel MOSFET. What I did have was a scrap motherboard. Now these are absolutely full of N-channel MOSFETs. So I got the old hot air out and I swiped a few of the N-channel MOSFETs off that. Unfortunately, they're really designed for low voltage but very high current switching applications. So they're not really ideal for what we're doing with it. But nonetheless, I knocked up a little circuit, which is literally just I'll show you that. I did this on a little bit of strip board. I mean, it's a surface mount device, as you can see, and I've literally had to bodge it on there. So we've got a N-channel MOSFET on there. Now that actually worked quite well. Apart from that's got like there's no gain there at all. It's not really the right component. We're running it nowhere near how it's meant to be run. But what I did, I've ordered some suitable N-channel MOSFETs, so as soon as those arrive I am going to have a go at making that again, actually with a more suitable component. So I thought, right, let's have another idea. Let's go down the op-amp route. I don't know why, I've got loads and loads of op-amps. I can't bloody find any of my stocks of new op-amps at the moment. So what I ended up doing, I've got some bits from a scrap sound desk. I think it's an old Soundcraft or something like that. So I swiped some op-amps off that. And what we ended up with was, they are, I'll have to put my glasses on to be able to read the thing on this. They are TL072 CPs, just a standard, I think pretty much general purpose audio op-amp. Now they should be absolutely ideal. Problem with, well, a lot of op-amps, especially ones like have been salvaged out of an old mixing desk like that, these are really designed to run on a dual voltage supply. So you have like plus 12 volts and a minus 12 volt supply. I found a circuit. That's not to say you can't use them on a single rail supply, but you have to do a little bit of faffing about to do it. Now I did find online a circuit using one of these op-amps and a single rail supply, which is designed for a ceramic phono cartridge input. Now I've buggered about with that circuit for probably 2 days now, off and on. I built it up on a little board like that. I've been over it over and over and over again, and I have had it working slightly, but basically all it wants to do is oscillate. It's very, very, very unstable. I'm not sure. I kind of put it down to that fact that it's not using the plus and minus supplies. It's using a rather dodgy potential divider to give a 12 volt and like a variable from like 3 to 6 volt supply, and supposedly using that to drive the op-amp. Now I've been reading up on doing this online, and people say yeah, you can get away with it, but for some reason I don't seem to be able to be getting away with it on there. So what I've thought I'm going to do, I'm going to build a separate power supply for the preamp stage in this. I mean, this is probably, it's going too far for this crappy little record player, it really is. But I really do want this thing to sound as good as possible, and I can't see why we can't actually get an RIAA compliant preamp stage to work in this. But if we're going to do that, then we might as well actually build a separate power supply, so it'll give out a plus 12 volts and a minus 12 volts, regulated, nice and stable, to actually drive a preamp stage built on an op-amp. Doing it that way, it gives me a massive scope in different op-amps I can use, and different circuits which are out there that other people have tried, which have, there's loads of circuits for driving these ceramic cartridges using in a op-amp. I'm sure that's what they do in like the modern Crosley style players, because I mean, they don't sound too awful. I mean, I know the crappily made and they are cheap. That's mostly down to the plasticky decks on them, to be honest. The electronics in them don't sound too awful, so they must, you know, they must be doing it in that way, and I can't see why we can't recreate that in here. Anyway, I'm going to bop off away. I'm going to see if I can just come up with some kind of little power supply unit that we can build into this, and then have a look at perhaps another preamp stage, actually just based on a single op amp, and just see if we can go from there. So I'll be back in a sec. Okay, we're back. Actually, a few days have gone by since I started making this video. Things kind of got in the way and I had to put it to one side. But I have been doing some more fiddling about. Basically, I couldn't find a suitable transformer with 2 tap-ins and a centre tap-in to make what I was describing earlier. What I did find was this. I don't know if you can just make that out there. I don't know what it's out of. It's an old power supply out of something, and I think I'm actually going to box that up and make a little bench power supply out of it, because it's quite nice. It's got plus 5 volts, minus 5 volts, plus 12 volts, minus 12 volts, and ground. And it gives them each out at 800 milliamps, which is more than enough for playing with this kind of thing. So I have ordered a couple of little transformers. I've got a few ideas actually what I'm going to do power supply wise, but I have ordered a couple of little suitable transformers. I think they give about 14 volts or something like that, AC output. So once it's rectified and everything, I can easily get a nice stable plus and minus 12 volt supply out of that. Make a nice, cause it's only tiny as well. It's only rated for about 500 milliamps or something like that. But you don't need a lot. The op amp doesn't draw a lot of current. All we really need is, like I said, the plus of the plus and minus supply rails. What I'm going to do actually, I'm going to cut away from this video and just cut to me actually explaining some of the electronics with the op amps and running it in plus and minus 5 volts mode, and just go through a couple of my scribbles. I've got loads and loads and loads of scribbles like this on pieces of paper that I've done as I've been trying various different preamps in this thing. So what we'll do is we'll cut away from this video and we'll go and have a quick look at these, and then we will pop back and listen to what I've actually got working up to now. So we'll pop back now to the other video. Okay, let's have a quick look into the circuits that I've been using to try and get this to work the way I want it to. And the first thing I tried was this. Now what we've got, this is like a really simple, just 1 transistor amplifier, and you heard me play the player in a couple of videos back when I built that. That was oops, just get it. That was this circuit here. Now this worked. It gave us plenty of gain, even though it's just literally just one very simple 1 transistor amplifier. So that gave us plenty of gain, but we do have an impedance mismatch. There was no matching between the output of the cartridge and the ceramic cartridge and the input of this. This is expecting quite a low impedance input, and obviously the ceramic cartridge is quite high impedance. Now I did try and improve that a little bit, basically by fitting a low pass filter to the input, so that would roll off a lot of the high frequencies and allow the low frequencies through, and that did work. To some extent it made the sound nicer, but it killed a lot of the volume. Now I could have I was considering at that point then perhaps building perhaps a 2 or 3 stage preamplifier, which would probably get around that, but it's still not the best way to go. So I thought I'll try an improved design. So I built this version of it. I used a different transistor, but it's still basically general purpose MPN transistor. The only real difference between this one and the last one, I did away with that what did I just call it, the filter there, the low pass filter. My brain's starting to fry. Basically I did away with the low pass filter on it, and what I did is I put a couple of 1 meg resistors essentially on the input here. So we've got that 10k there, we've got that capacitor. I basically come from here down with a 1 meg resistor to give it a little bit of loading, and again, yeah, it worked, but it seemed to really kill the actual volume, and still it was still very, very thin, the sound from it. So I kind of give up on that. I thought, right, let's go down. Let's just say I thought I'd try and improve that after that by fitting that. What we've got there is a N-channel MOSFET. So this is one I actually salvaged off an old computer motherboard. It's not really designed for this application, but it is a high impedance device rather than a low impedance device. Although it won't give a lot of gain, like I said, it's generally designed as a switching device that in the application it was used from. It's very high current, a low voltage one. I would ideally, like I said, I've ordered some actually for future playing about with a little N-channel MOSFET, which has got a lot higher gain to it. But it's still a low voltage, low current device. I basically added that to the start of the circuit, did away with that 1 meg resistor I put in, and again that added a bit more to it. That it didn't sound quite as thin, but it still didn't sound quite right. So what I thought I'd try next, I kept hold of that, and I had to go at building that. Now this is using a little op amp. In fact, it's 2 op amps in there in one little package. And this is the circuit. I found this online. Like I said, this is nothing new or spectacular. I found this circuit. Now this uses an op amp, but it only uses a single rail supply. Basically, you can use dual rail op amps on a single rail supply, but you have to do it. And basically, what you have to do is you have to bias part of the op amp with a lower voltage than your supply voltage. So it doesn't actually have to be like plus 12 volts and minus 12 volts. I don't like doing it, and I've not had a lot of luck actually getting it to work really, really successfully. Let's see if I've got something I can. Not that. Let's try and find. So I've got lots and lots of scraps of paper here. I do tend to, when I'm working on stuff like this, just jot ideas down on little bits of paper, and then I end up with loads of little scraps of paper like this. Now where are we up to? That's a power supply one. Right, there we go. Now this is a op amp being driven by a single rail supply. So as you can see, we've got 12 volts going in. Where you would have the minus 12 volts, we've got that grounded. Now we've got the non-inverting and the inverting inputs to the op amp. And let's say we're using the non-inverting input up there. What we need to do is we need to create a potential divider with the 12 volts. Say we used, I don't know, 1k or so resistors there, we'd have about half the voltage. Say, so we'd have 6 volts on the opposite leg to the leg that we're using. So if we're using the inverting input, we'd have it on the non-inverting input, and vice versa. Basically what that does, that biases the op amp. Like I said, they're really designed to be biased, so really designed to be driven with a plus 12 volt supply and a minus 12 volt supply, but doing that you can get them to run on a single rail supply, and basically that's what this circuit here did. Now I built it up and I really couldn't get it to work very well. Like I say, it's built exactly as this was this is designed here. It did work, but it was very, very, very unstable. I only had one of the NE553 op amps as well. I did try the circuit with the TL072, which I've got quite a few of. I managed to salvage a load of them out of some old mixing desk parts. I can't find my collection of op amps. I've got a huge selection of all different op amps, some new, some used, all sorts, and I cannot find them anywhere at the moment. So I'm scratching around. I'm hesitant to buy some more because I know I've got lots. It's just I cannot damn well find them at the moment. As soon as I find them, it'll make some of these projects a little bit easier. Anyway, so like I said, I was not having a lot of luck with this circuit. So I went back on line. I went to have a look at some other ideas, and what we came up with, and it's incredibly simple, was that. Now that's what when we skip back over to me playing about in my workshop, this is the circuit I've actually got set up. You actually hear the record player play through at the moment. So what we've got, it's like I say, it's incredibly simple. We've got isolation capacitor, input isolation capacitor. We've got a 10 meg load going straight, so that's so basically we've got the ceramic cartridge coming in, a 10 meg load on the circuit, right into the op amp. The op amp is now being driven plus 12 volts and minus 12 volts, so we've got a dual rail supply on it, and then the output straight out. Now I've run it through a tone control, a very simple tone control, which I've got a circuit that I've scribbled down somewhere. What have I done with that? That's a tone control I tried earlier on. Where's my tone control that I've I can't find my other piece of paper with the other. What have I done with that now? Oh no, it's there, you silly sod. It's still on the book. So basically I knocked that up. Now this is out of one of my old Mullard, late 1960s Mullard transistor guidebooks. It basically gives you a lot of circuits using Mullard transistors for Mullard components for various, you know, record players, radiograms, radios, FM tuners, you name it. There's all like stock circuits in there, and this was just a stock tone control in there. So I made that up, and I've got that circuit outputting into that tone control, straight through that tone control into the amplifier, and that's how I've got it working at the moment. Now the thing is, it's not ideal. It works quite nicely actually, and you can even hear, you know, a fair bit of bass response, but it's not. I think it needs more bass. Personally, I think it just needs a little bit more bass. So what I thought about doing, I've got a few options here. I did come across that circuit. Again, this uses a TL072. It only uses one half of it because you've got 2 op amps per device in them, and it's a bass boost circuit. So basically it cuts the high frequencies and amplifies the low frequencies and kicks it back out. Now I'm wondering whether I can combine those two circuits. So we've got the preamplifier going straight into a bass boost, and we come out of that into the tone control. Now we could use the passive tone control that I've just sewn in the circuit there, or this was another thing. Rather than the bass boost, what I was thinking of was basically that. So again, we've got the same preamplifier stage there with half of the TL072 going into an active tone control. So we would have a bass and a treble control. But what we can do with that is basically we can use the bass control, and we can put a preset pot for the tone control, and we can set that so it sounds nice, and then we use the bass control up through the front of the top of the record player to vary between, you know, a lot of bass and less bass, and just leave the treble preset. I think that would work quite nicely. I mean, it's either going to be this circuit or the bass boost circuit, or a combination. Might even end up doing something using all three of these, but we're not going to mess with this until the next video. Like I said, we might as well get back now and have a listen to basically that coupled up to that tone control like that is basically how I've got it set up now. So we've got the one half of that TL072 going straight into that treble control there, which is a 2K pot with 150 nanofarad capacitor off the end of it, which then goes through into a bass control, which is a 3 nanofarad capacitor with a 20K pot that actually goes across it like that. Now I've been having a bit of a fiddle about, and to be honest, I've put all sorts of different value pots there, and it doesn't really seem to make a lot of difference. You still, you know, it doesn't affect the audio. I presume if I change that capacitor and try some different values for that, we could get some different results. But again, like I said, I'm still really just playing about with this, but that's where we're up to on the circuits so far. So I think our final circuit is probably going to be a combination of one or more of this. So we're either going to be using that bass boost, we might either use the I've not built that up yet, so I don't even know how well that works. I think that might be the next thing I'm going to do, is build that circuit up, perhaps on a separate board. And we'll see, because like I said, I've got plenty of the op amps, so it doesn't matter if we use 2 op amps rather than 1. I might just build that circuit up on a test board and see how that works. I'm also going to build that bass boost circuit up on a little test board, and again we can see how that works. So anyway, let's get back to actually listening to how it sounds at the moment. So back to the workshop. I'm going to do something about the back of the arm here, because we fitted them nice flexible rubber grommets, but the hole that the actual arm goes through there is very, very tight, so I'm going to probably put a drill through that, just loosen that hole up a bit so the grommets can do the job, and we'll get a little bit of compliance on the stylus and the arm through that. So there's obviously there's a new mat to go on there, which I found a mat amongst my stuff. It's an old BSR mat that I can modify to fit this turntable, but the problem was it's a bit hard, and it's kind of like curled up like that. So I've had it for the last week or two, sat under a couple of heavy books, and then with a radio sat on top of it. So I'm hoping that will have flattened out nicely, and I'm hoping we can do something with it and get it to fit to this deck, because my tempering mat's not ideal. I can't actually play LPs on it at the moment with that temporary mat in place. But let's put the turn it down. You hear it actually goes fairly like. Tone control works just about. Cuts in a bit. I think I've got a log pot in there. It should really be a linear. Let's turn it down a bit. For that tone control there, I've actually got a log pot in place. I was experimenting with different values for that tone pot, and it doesn't seem to make a whole heap of difference. I think in the original circuit that I showed before, it was something like 20k. That's a 1 meg, and that still works. In fact, we can actually get rid of it completely and take this off. We completely bypass the tone control there. Well, bypass the volume control. We're just going through the low pass filter there. We've got the tone network that I showed, I said in that description here. I actually ended up using a little trim pot for the treble control. And I'm basically just using this pot as the bass control, as the tone control. But as I said, in some of them other circuits I'm going to look at, we actually do have a an op-amp driven tone circuit, which we will look to see if that gives any improvement. But so far, I mean, electronics wise, I think I am getting there. You know, it's certainly sounding okay. I just think it could do with that little bit more bottom end. And this is, like I said, this is something people have commented about trying to get these cartridges to sound good, is that they can sound a little bit thin. I think we've sorted the majority of the issue out with that first preamp stage. So we've only got one stage of preamplification from that op-amp in there now. Next video, what I'm going to do, I'm considering actually rather than having all this like this in the final finished product, whatever I finally build as the preamp, I'm either going to use a piece of this, like I did to build the power supply and a couple of the other prototype preamps, or I'm going to use actual piece of PCB and etch it. I've not done that in years and years and years. I'll have to see if I've still got any etching stuff kicking about. I think I've got some ferric chloride and some etching pens and some PCB and stuff. So we might actually etch a circuit board to take the preamp. So what we'll end up with is we'll end up... I mean, if we're doing that, we could even incorporate the power supply for the preamp on that board, couldn't we? That might be the way to go. So we've only got a separate transformer. We're going to, they're tiny, these transformers. They are only, you know, about 1 inch, I think, from memory. So we'll mount the transformer, and perhaps we'll actually build the power supply for the preamp on the same PCB. Then the preamp, and so we just have the volume and the tone control wires coming off to the actual controls, and obviously the wires going across to the power amp and what have you. But anyway, I'm going to leave it there for now. I think I've already rambled on far too much about this, but as you can see, we are getting something that's actually probably going to sound quite decent. I'm just hoping I'm going to end up with something that will sound better than the original player that this is being based on. So anyway, I'm going to leave it there for now. I hope you enjoyed this little update, and apologies for the length of time between them. Like I said, I'm not in the best of health at the moment. My health's not great, and it just coincides with the fact that everyone seems to need the syncs unblocking and other various tasks that I end up performing. Anyway, like I said, I'll leave it there for now. I hope you enjoyed this. So thanks for watching and goodbye.